Today we will discuss sequences and series and their different branches related to math. What are sequences? It's a list of numbers that are in order. For example, this is a sequence. 1, 2, 3, 4, and so on, because they are consecutive numbers. There are two different types of sequences. Arithmetic, when sequence of values follows a pattern of adding a fixed amount from one term to the next. This is an arithmetic sequence. 1, 3, 5, 7, 9, and so on, because you are adding plus 2. 1 plus 2 is 3, 3 plus 2 is 5, plus 2, 5 plus 2 is 7, and 7 plus 2 is 9, and so on. A geometric sequence is when a sequence of values follows a pattern of multiplying a fixed amount that is not 0 times each term to arrive at the following term. For example, we have 1, then we have 3, then we have 9, and then we have 27, because we are multiplying each value times 3, so 1 times 3, 3 times 3, 9 times 3. We have three formulas we can apply for an arithmetic sequence. The first one is un equals u1 plus n minus 1 times d, where un is the position n and the value that is in this position. u1 is the first value. And the number of the position, and d is something called common difference. The common difference is the fixed amount that separates each successive number in the sequence. It can be negative or positive depending if the sequence is ascending or descending. You will only need to replace the values that are given to you. Now, there are other formulas we can use. The next one is to find the common difference. This formula will be un minus un minus 1. This means whenever you subtract this value from the value it was before in the sequence, it will give you the difference each half. For example, in the sequence we have of 1, 3, 5. If you subtract 5 minus 3, it's going to give us 2. 2 is the common difference. Now, we have another formula that we can apply. This formula is used to find n. So when you are given u1, you are given another value in the sequence and you're given d, but you don't know what's the position of this value. So this will be n equals un minus 1 divided over d plus 1. So for example, you are given that u1 it's equal to 3, and you are given that un it's equal to 9. So you will just replace n, and that the difference is 3. So you will replace 9 minus 3 over 3 plus 1. So n equals 3 over 3 plus 1, and 3 over 3 is 1, so n equals 1 plus 1. So we know that n equals 2. So the value in which we can find 9 is 2. So U9, U2 would be 9. Now let's try to apply the first formula, that was UN equals U1 plus n minus 1 times d. So let's write over here the formula UN equals to U1 plus n minus 1 times d. So in our first exercise, we have that this easy sequence 2, 4, 6, 8, 10, 12, and so on. So first we need to find d. So d would be 4 minus 2. This means that d equals to 2. Let's try to write this in another color so that we don't get confused. So we have 1, that it's exercise 1, and we have the answer of D. Now we know that U1 equals to 2. But what about if we want to find U100? So it will take us long to use the calculator for this exercise only by adding 12 plus 2, 14 plus 2, and so on. So that's why we use the formula. So U100 equals to 2 plus 100 minus 1 times 2. So U100 equals to 2 plus 99 times 2. U100 equals to 2 plus, so 99 times 2 equals 2. Let's move on this into here. So U100 equals to 2 plus 188. So we know that U100 equals to 200. And that would be all. Now, when we want to find a geometric sequence, we will only need to apply two formulas. The first one, that is the general one, is UN equals to U1 times R to the power of n minus 1, where U1 it's the value of n position in the sequence, n position. U1, the same, is the first value. R is something we call the common ratio. What is this common ratio? Well, The common ratio indicates the following value in the sequence. There cannot be any negative ratios, but there are decimal ratios when the sequence has decimal values. And then is the position. Now the other formula we have is to find R, that just as we find D, is to play with the values of the sequence. R will be UN divided by UN minus 1. So it's just the same to divide one value to the value it had before in the sequence. That's why it is minus 1. So one clear example of this would be if we had 3, 15, 75, 375. And the question tells us to find U10. So what is U10? So first we need to find a common ratio. For that we divide 15 into 3. Like that we will know that the ratio is 5. Now with that we just use the formula we know, which would be U10 equals to U1, which is 3, times R, which is 5, to the power of 10 minus 1. U10 equals to 3 times 5 to the power of 9. U10 equals to 3 times 5 to the power of 9, which is a really big number. It is U10 equals to 3 times 1953125. Now let's continue over here. U10 equals to, you can do it with your calculator, 5, 8, 5, 9, 3, 7, 5. And this would be our final answer for U10. Now we must continue with series that are the sum of the terms of an infinite sequence. So a series would be something like this: 1 plus 2 plus 3 plus 4 plus 5 plus 6, which this will give us 21. An arithmetic series is the addition of a whole arithmetic sequence. It is recognized by using Sn, the addition of the sequence till position n. The sum to infinity for an arithmetic series is undefined. That's why we don't have infinite arithmetic series. Also, we have geometric series that are the addition of a whole geometric sequence. It is recognized by using Sn, the addition of the sequence till position n. We do have infinite geometric series that will be addressed later on. Now, for arithmetic series formulas, we first need to understand what is the Gauss addition. So, Jonathan Carl Friedrich Gauss was a German mathematician who contributed significantly to many fields, which includes algebra, statistics, differential geometry, and many more. And he gave the name to the Gauss addition and its formula. What is the Gauss addition? It is when we write the same numbers but arrange them opposite and pair each number and add them in the same sequence. So for example, if we want to add 1 plus 2 plus 3 plus 4, We will arrange the same down and add them, but opposite. So it will be 4, 3, 2, and 1. And now we add them. This will give us 5, this will give us 5, this will give us 5, and this will give us 5. And now we add them, and this will give us 5 plus 5, 10, plus 5, 15, plus 5, 20. And that will be the arithmetic series of this sequence. Of course, we can apply this concept for more difficult numbers, but it's just to understand what is the Gauss addition. When Gauss discovered this, he decided to create the following formula, which is Sn equals to n times n plus 1 over 2, which means S series of n number, that is the position in the sequence, position sequence, the same in the n divided by 2, this n is the same, and this n is just the same. So what would happen with the problem we just solved? It's easy. We will rearrange this formula for the problem, and it would be S of 5 because it's until S of 4 because it's until digit 4 equals to 6 times 6 plus 1 divided by 2. And this will give us the same. So if you take your calculators and input this number, you would find out that we have just the same value as before, which is 20. And that's why he created this formula, which relates to the pairing we did before, and explain why we must divide by 2. We must divide by 2 because we only want the addition of one column, but we must use 2. And that's basically Gauss addition. Now why do we need to know Gauss addition? Because in order to understand the real formula for arithmetic series, we must combine it with Gauss addition. When d in the sequence is not 1, you must change the Gauss formula. If d is given in the exercise, you must use this formula. So, if you're given an example when the common difference is clear, you need to use this formula, which is the summatory of position n equals to n divided by 2 times 2 u1 plus n minus 1, and this times d, which will just be to replace the values that are given to you by the exercise. But sometimes the exercise won't give you the value of d. That's why there's also another formula, because mathematicians always think forward, because will be summatory of n equals to n divided by 2 times u1 plus un. So of course, instead of giving you the value of d, you are given the value of un. And that's all with the formulas. So now to understand more clearly what these formulas are about, I will give you the first example, which would be what happens if you tell you to find the addition of a sequence until its third value. So you need to find S of 3. And you're given that U1 equals to 2. And the common difference also equals to 2. So that's why we must use our first formula. So it will be S3 equals to 3 over 2 times 2 times 2, that is U1, plus 3 minus 1 times 2. Now we can input all of these at the same time in our calculators. Now if we input this in our calculators, give us that S3 equals to 12. You can check it out. Now, if we have another exercise, when you are given that, you need to find S3, and they tell you that U1 is 2, and that U3 is 6, so it will be S3 equals to 3 over 2 times 2 plus 6. We will know, and if we input this in the calculator, we will find out that S3 is the same as 12 because we were using the same sequence for both exercises. Now, the formulas for geometric series are easier because there's not much theory behind it. The formula is just Sn equals to U1 times 1 minus r to the power of n divided by 1 minus r. It can also be the same, just changing the order of the values like this, but it will not affect the final answer, so there's no such big deal by using any of the two formulas. Now, let's make an exercise to understand this. So what about if they told you that, so first exercise, to find the addition of a geometric sequence until it's 10 values, so you need to find S to 10. If its first value, so U1 equals to 3, its 10th value equals to 1536, and the common ratio equals to 2. So we will just arrange the formula for S10 equals to 3 times 1 minus 2 to the power of 10 divided by 1 minus 2. And if we input this in the calculator, it will give us that S of 10 equals to 3069. And that's all, very easy to use. Now, there's something we know of infinite geometric sequence, as we can see in the picture, is when the common ratio in the sequence is between -1 and 1, because even though the addition of the sequence increases the values, it will never lead them to reach 1. It is infinite, which means it is convergent. For example, if we have the following sequence, the number will just get smaller and smaller just as its addition. To calculate it, we use the formula of e to infinity equals to u1 divided by 1 minus r. So for example, if they tell you to find the addition of the following sequence, we can calculate r by just taking any of these values. So if, for example, if we divide 14 over 28, this will give us that r equals to 0.5. So we can see in here, this means that is less than 1. So the addition of this sequence will always give the addition of the first value until there is a decimal plus 1. As we can see from the above exercise, 28, that it's the first value, plus 14 plus 7, and it gives us 49. Just as it explained here, and if we add 49 1, it will give us 50. That it was the answer that it gave us using the formula. Now there are two clear examples of this that are the chess problem, that it is said that the man who invented chess presented the creation to the king, and as the king was very amused, he told him that he will pay anything for him. And the chess inventor, that was very intelligent but not wise, asked the king this: for the first square of the chessboard he will receive 1 grain of rice, 2 for the second square, 4 for the third, and so on, doubling each time. Eventually, the king realized this would take more rice than he had ever grown in the kingdom and punished the inventor. This occurred because the sequence is going to go on forever, as every value can be double. So let's imagine that we have this board. It will start with 1, 2, 4, 8, 16, and so on, doubling each value, which would be infinite and thus impossible for the king. The other one is the Hilbert Hotel, the largest hotel in the world. It has infinitely many rooms. If a new guest arrives, the manager just asks all the guests to move to the next room. So if a new guest arrives, he will ask the guests of room 1 to move to room 2, the guests from room 2 to move to room 3, and so on. Every guest will move to the next room. And as there are infinite rooms, there will always be space for a new guest. If infinitely guests arrives, the manager asks every guest to move to the double of the room. So from room 1 to room 2, from room 2 to room 4, from room 4 to room 16. And as it was explaining here, as every number has a double and it's infinite, there will be vacancy for the infinite number of guests. But what happens if infinite buses arrives with infinite passengers? There will also be rooms for everybody. They just need to be accommodated by using prime numbers. So we will just eliminate the prime numbers, leave all the guests that are in a prime room, and then accommodate them in the other. So basically, this just makes infinite geometry. And down over here, we just have all types of infinite numbers, which are cardinals, ordinals, bad numbers, surreal, surcomplex, real line, long line, and absolute infinity, just to talk about of some infinites. Now there's another topic that relates to geometric and arithmetic sequences and series, and it's interest, that is a charge for borrowed money in percentage of the amount borrowed in certain period of time. The profit in goods or money that is made on invested capital that is used when you borrow money to a bank, to someone, when you have a loan. We want to know how much you need to pay back. The units are principal amount of money, that is P, rate of interest, that is R, our interest for n time, that is AN. Now we have one of the branches that is compound, that is the interest calculated on the initial principal and also on the accumulated interest of previous periods of a deposit or loan. It has the following formula: AN, so this means period time of N. So it could be 1 year, 2 years, or maybe 1 month, 2 months, 6 months. equals to P, principal formula, times 1 plus R, the rate of interest, divided by 100, since it's a percentage and we don't want any percentage, to the power of n, that's the time period. Now we have down an example. If they tell you to find the interest of 10,000 at a rate of 6% per year after 5 years, you just need to rearrange it for the formula, and it will give us this, and it will give us the following answer. So a tip would be to always keep all the decimals, because you need to be as precise as possible. Lastly, we have simple, that is the interest earned only from the principal amount. So the interest you have does not earn another interest. To calculate it, you use the following formula. So the same, a certain period of time equals to the principal amount times 1 plus R, again divided by 100 because it's a percentage, times n. Because since this time your interest is not affected, we don't have n multiplying everything, but only multiplying the rate of interest. The example is, what is the interest of 1,000 at a rate of 12% per year after 9 years? We can see that it just gave us this answer. And that's all. It will be everything for sequences and series.